Tigera and Fortinet have partnered to integrate Tigera Calico Enterprise and the Fortinet security fabric. In this video, you'll see how this integration enables FortiGate administrators to use existing FortiGate capabilities and policies to scale and secure Kubernetes workloads. The problem we're solving? Traditional IP-based access control doesn't work in Kubernetes, where workloads are ephemeral, typically stateless, and use short-term IP addresses. Firewalls don't have the context required to understand Kubernetes traffic, like namespace, pod, and labels. This makes it nearly impossible to troubleshoot networking issues, perform forensic analysis, or report on security controls for compliance. The FortiGate Calico Kubernetes controller enables FortiGate next-generation firewalls to control egress from Kubernetes pods to applications. It does this by dynamically populating Kubernetes workload source IPs and FortiGate address group objects. FortiGate can then natively enforce already defined firewall rules. Let's take a look at how this works using a simple storefront e-commerce application with microservices running in a typical 3-zone IP environment. In the demo, we'll scale the front-end service and show how the new microservice's IP address is automatically updated in FortiGate. Here we are in the FortiGate user interface, and you can see under address group is a DMZ address group being managed by Tigera Calico Enterprise. And this DMZ group is populated with one node from our storefront Kubernetes application, the front-end microservice node. In the address section of the FortiGate UI, you can see this node's current IP address. We have also defined a policy that allows traffic from the DMZ address group to access the Twilio API. Now let's watch what happens when we scale the front-end service. First, note that we currently have 5 microservices and 1 front-end service. Here we scale the front-end service by issuing a kubectl command to replicate this service. Inspecting the pods for our application, you can see we now have a new front-end service up and running. Returning to the FortiGate UI, we see the DMZ address group has been automatically updated with the new node where the front-end service is running. With no manual changes or updates to your FortiGate firewall rules, only the Kubernetes containers that should have access to the external resource, in this case the Twilio API, do. Traffic from other containers will be denied or dropped. Using the FortiGate Calico Kubernetes controller eliminates error-prone, time-consuming manual updates to your FortiGate firewall rules and reduces time spent on testing and debugging firewall changes by enabling automatic pinpoint egress access control from Kubernetes.